Hello everyone, let's learn about integration by part. At the end of this lesson, you should be able to solve the integration using integral by part. This is the formula that we are about to use. Did you still remember about the product rule formula of differentiation? Product rule for differentiation also has a corresponding technique for integration, and it is called as integration by parts. So today we are going to use and learn about this formula. But before that, let us know how we can get this formula. So let u is equal to ux and v is equal to vx. So we know that by a product rule of differentiation, we get uv prime is equal to uv prime plus vu prime. So to get back the original function, which is the product of uv, actually we have to integrate this part, which is integral of uv prime plus vu prime dx is equal to uv. So by looking at the integral properties for addition, so we can separate this part, which is uv prime and vu prime, and then is equal to uv. Then we have to move the integral vu prime dx to the right hand side, to the other parts. So we get integral uv prime dx is equal to uv minus integral vu prime dx. So at this v prime dx and also u prime dx, we can actually simply note as dv and du respectively. So here we get the integration by part formula, which is the integral u dv is equal to uv minus integral v du. In order to use this integration by part formula, we have to choose u. So there is a priority of choosing u techniques, which is called as LOPET. So law stands for logarithm, P is polynomial, E exponential, and T is for trigonometry. So we have to follow this order. With the highest priority is the logarithm, and the least priority is trigonometry. So let's jump into example 7. Evaluate the integral x squared ln x dx. So by LOPET, we have to choose ln x as u. So we get u is equal to ln x. And the rest of the integrand, which is the x squared dx, we choose as dv is equal to x squared dx. So let's solve this one by one. So as u is equal to ln x, we have to differentiate with respect to x. Then we will get 1 over x. And then rearrange du, we get du is equal to 1 over x dx. Now, move to dv is equal to x squared dx. Okay, for this part, we have to integrate dv. So when we integrate dv, we simply get v, and the other part is the integral of x squared dx. So at the right hand side here, we have to solve the integral parts. Then we will get v is equal to x cubed over 3. Now we can substitute all the formula using integration by part formula, which is uv minus integral v du. So we substitute all the value that we get. So we have ln x cubed over 3 minus integral x cubed over 3 in bracket 1 over x dx. So we simplify, we get x cubed over 3 ln x minus 1 over 3. Solve the integral, we get x cubed over 3 plus c. We factor out 1 over 3, x cubed, we get x cubed over 3 in bracket ln x minus 1 over 3 plus c. Example 8. Evaluate the integral e to the power of x cos x dx. So we choose e to the power x as u according to LOPET rules. So we get u is equal to e to the x. So the rest of the integrand cos x dx, we note as dv is equal to cos x dx. And then we solve du, we get du is equal to e to the x dx. And at the dv part, we integrate. So we get integral dv is equal to integral cos x dx. So look at the integral properties, table of the integral properties. So get v is equal to sine x. So now we substitute into the formula. We will get e to the x sine x minus integral sine x e to the x dx. So as you can see here, the integral sine x e to the x dx we haven't solved yet. So we have to do the repetitive integration by part again. So here we have to choose e to the x again as u and the rest of integrand sine x dx as dv. So we have to do the same thing again and then substitute again at this part. So now we will get in bracket negative e to the x cos x plus the integral e to the x cos x dx. So now we simplify, we get e to the x sine x plus e to the x cos x minus integral e to the x cos x dx. So now you notice that there is two same integral, which is the integral e to the x cos x dx. Okay, so we can bring the integral e to the x cos x dx into the left hand side. Now we get 2 integral e to the x cos x dx is equal to e to the x sine x plus e to the x cos x. And then we can actually bring 2 at the right hand side. Now we get 1 over 2 in bracket e to the x sine x plus e to the x cos x. And then don't forget to plus c. Now we have solved this kind of problem. There is another alternative method which is known as tabular method. The priority of choosing u is also similar, which is a loped. But in this alternative method, we should create a table first. With the left column is sign, which is we need to put positive minus repetitively. And then at the middle of the table, we have to differentiate u. And the last column here, we have to let dv and integrate dv. And then we have to connect at like this arrow with the connected sign. Okay, let's look at example 9. Evaluate the integral for x e to the x dx. So we have to choose u according to loped rules. We have to choose the polynomial, which is for x, and then we have to differentiate again and again. So we get 4, and then we differentiate 4, we get 0. Then we have to differentiate this until we get 0, or we cannot differentiate it again. Okay, now moving on to the right column, which is integrate dv. So we know that dv is the rest of integral, which is e to the x. So we have to differentiate e to the x, we get e to the x, and then differentiate again, also we get e to the x. Then we have to stop at where we have stopped the differentiation process. So now we have to create this arrow, and it is connected to the sign at the left column here. So we know that is a positive 4x multiplied by e to the x. So get positive 4x e to the x. And then the next sign is negative, and the connecting arrow is 4 multiplied by e to the x. So get negative 4 e to the x. And then there is no more connecting line, so we have to plus c. So now we have solved this example 9 problem. Okay. Example 10. Evaluate the integral ln x over x cubed dx. So according to the loped rule, we have to choose ln x as u. So we write ln x at the middle of the table at the differentiate u column. And then before that, let's make sure that at the sign column, which is the left hand side column, we have to put positive minus repetitively to stand by. Okay, and then differentiate ln x, we get 1 over x. Differentiate again, we get negative 1 over x squared. Differentiate it again, we get 2 over x cubed. This process is repetitive until we need to stop somewhere. Okay, now moving on to the right column, which is the integration process. So the rest of integrand, as we have already put ln x as u, then we have another 1 over x cube. So we write 1 over x cube, then we have to integrate, integrate it, we get negative 1 over 2x squared. Integrate again, what we get 1 over 2x. Integrate again, we get 1 over 2 ln x. Okay, so this also repetitive. So how do we need to stop? How we determine where to stop? Actually, at any of this row, if we multiply, it is actually it equal to the integral by that product. Okay, for example, I choose to stop at the fourth row because the integral of this product of the 2x cubed multiplied by 1 over 2 ln x, we will get the integral of ln x over x cubed dx, which is actually similar like the things that we need to evaluate, the integral that we need to evaluate. Okay, so now we have to write first so that you can see. Okay, so the integral ln x over x cubed dx is equal to, okay, as you can see, the sign positive at the first row, okay, connected to ln x. Follow the arrow, then we have to multiply by negative 1 over 2x squared. So at the first term here, we get negative ln x over 2x squared. Okay, the second term is connected to the negative sign, multiply by 1 over x. Follow the arrow, we have to multiply 1 over 2x. So basically, we have negative 1 over 2x squared. The third term is connected with the positive sign. Okay, along with negative 1 over x squared. Follow the arrow, we get 1 over 2, multiply by 1 over 2 ln x. So get ln x over 2x squared. So as I stop at the fourth column, fourth row here, so we have to multiply 1 over 2 ln x to 2 over x cubed, and it's connected with the sign of negative, so we have to put negative integral of ln x over x cubed dx. So remember, we multiply any function in the same row, we have to put integral and dx, and connected where the sign is at. Okay, now we have to simplify it. So notice that we have two same integral, which is ln x over x cubed. So we can actually move into the same part, which is the left hand side. So now we get 2 integral ln x over x cubed dx. And the rest part we have to simplify it. So we get negative 2 ln x over 2x squared minus 1 over 2x squared. Then cancel out 2, and also we move 2 to the right hand side, then we get negative 2 ln x over 2x squared minus 1 over 4x squared plus c. Now, that's all for the integration by part using tabular method. So let's check your comprehension.